Hi, Dan Forrester here with San Francisco cryptocurrency developers, and I'm sitting here today with Mark Miller, who from Agoric, and Mark has a tradition of writing cryptographic papers. He was one of the cypherpunks. What's a cypherpunk?
So a cypherpunk, there was a movement, certainly starting in the early 90s, and it might have even been the late 80s. I'm actually not quite sure when it got started. But there was this recognition that cryptography is a great new enabler for creating safe, rule-based frameworks of interaction that can provide for us in a decentralized manner many of the same kinds of rich, safe interaction that we've normally, historically, always had to turn to law and governments for. That suddenly there was this incredible new technological enabler that would enable us to create, in the digital realm, frameworks for interaction that had strong security properties and strong decentralization properties, so that we could, the way I like to put it is, the opportunity is that by lowering the risk of cooperation, we can build a more cooperative world. That cooperation in some complex attempt at a cooperative relationship entails some forms of risk. You can think of the risk as the price of the cooperation. And by creating structures of cooperation that are expressed digitally in such a way as to be self-enforcing, as to be able to be structured in such a way that if things go well, you and I can realize the benefit from our cooperative opportunity, but if things go badly, we're each protected from each other's misbehavior.
It's my understanding that this gave birth to a lot of the theories that Satoshi Nakamoto was capable of crystallizing in the blockchain, and that you had a lot to do with developing this field and decentralized markets. What are decentralized markets?
Okay, so in 1988, Eric Drexler and I published a set of papers that we refer to collectively as the Agoric Open Systems Papers. These are available from our website, agoric.com. And these Agoric Open Systems Papers, this is before the term smart contract had been coined, and before the general concept had been invented. Nick Szabo later had this wonderful concept of smart contracting, as well as coining the term for it. But once we had the concept, I think you can now look back on those papers and say a lot of what was being described in those papers were smart contracts. But there were some differences. What we were doing was we were concerned primarily with distributed computation. This was back in the mid-'80s we were doing this work, and we could look forward and see that there would be large networks of computation across distributed systems interacting with each other, and that the issue of scheduling, of resource allocation, of all of these computer science problems that had been up to that point dealt with in a centralized manner would obviously break down in a world that was that decentralized. So what we were conceiving of was to bring trade and price mechanisms into computation so that, for example, there would the processor scheduling would be auctioned off So the scheduler would be reconceived as an auction process, where the suspended process whose bid was highest would receive the next time slice, and this is the way in which the CPU would be scheduled. So we had this nice system called the escalator algorithm that turned out to inspire a lot of the modern work on proportional share scheduling. The key thing about the escalator algorithm and the whole notion of allocating these things through an auction process is you get congestion pricing. If there's more demand for the CPU, the price goes up. Okay? And likewise with memory space. So there we had something called the rental auction for memory space. So we were really thinking not primarily about solving security problems between humans. That didn't become our focus until we were sort of re-inspired by all of Nick Szabo's ideas about smart contract. Our focus in the Agoric Open Systems papers was largely about this purely automated world of computation engaged in market relationships with other computation and using dynamic pricing to guide resource trade-off decisions, essentially to bring the Adam Smith invisible hand into the software system. So each process, each object being led by prices to act in, so to speak, its self-interest, to act in the way that the prices guide it to act, ends up making decisions that ends up creating an overall better allocation of resources in the system. And now we're finally starting to see that happen in reality in some degree, but it's finally starting.
So you at Agoric have been developing a new fabric, I believe you referred to it as, to help build this layering and the ability to have diverse networks where machines talk to each other. How does the fabric work? And I believe you used the term chainmail?
Right, okay. So let me get to that in a moment. Tie up the previous thread. And I'll
Sorry
get to
about that. You're right.
It's all right. So we developed auctions. We developed various kinds of market institution, things that would, and these were all programs. These were all automated programs interacting with each other and creating complex frameworks of interaction so that each of them could interact in a way that bounded their risk to the others. In fact, these frameworks were smart contracts. The difference in bringing smart contracts out to the modern world was that the assets at risk to the contract, the assets that the contracts are manipulating, are themselves often things that are themselves human significant. So humans care about the particular rights that are at stake. So it's a much more intimate mixing of the rights and activities as held by the software and the embedding into the world of humans dealing with other human beings. And cypherpunks was definitely very formative with regard to refocusing on the security problem that the digital realm solves is not primarily program to program, but primarily human to human with regard to security issues that matter to human, but facilitated by this whole computational infrastructure of smart contracts creating these frameworks of cooperation. Okay. So by fabric, the internet and the World Wide Web are fabrics in the sense that I mean the word fabric, which is there's no big center of the whole thing. There's no one central place that control emanates from or anything like that. It's this decentralized network of relationships where things are dealing with other things that are adjacent in some sense in the network. And that the overall properties of the system emerge from all of these local interactions. And what we're doing with distributed object capabilities, and then at a higher level with the composition of rights and smart contracts through higher order smart contracts, is we're trying to create a world-spanning fabric of rights and contracts and cooperative secure interactions in very much the same sense in which the World Wide Web has created a world-spanning fabric of documents linking to each other. We want to create a worldwide fabric of market relationships building on and manipulating and collaborating through other market relationships, an ecosystem of interacting market components that reflects the richness that we expect, that we find so inspiring in the ecosystem of markets in the real world.
So now you work at Agoric. How long have you been there, and what is your job title? I believe you're the chief science?
I'm the chief scientist.
Chief scientist.
Chief scientist at Agoric. So I started at Agoric in April, but I've been working on the ideas, as I mentioned, for over 30 years.
Yes.
And I've been staying on mission in many ways for the entire 30-year period, with distractions here and there.
Been an evolving ecosystem.
Yeah, but yeah, Agoric has been a great opportunity to realize the visions that we've all been working towards for so long. There's certain catalyzing time for markets, for market ideas. Hypertext started with an article by Vannevar Bush in 1945, published in the Atlantic Monthly, called As We May Think. And it started, Vannevar Bush was explaining hypertext in terms of microfiche technology, because that was all they had to imagine it with. But what he was imagining was clearly what we would now describe as hypertext. Again, missing some elements that we can now see in retrospect, but still having the core idea. Douglas Engelbart and Ted Nelson were exposed to that when they were children. They grew up to be the grand visionaries of hypertext, and but then after many decades of people doing great work on hypertext, suddenly in the early 90s, hypertext just took off and covered the world. So for those of us who cared about hypertext, when you suddenly see the explosion, the phrase in my head, I was involved in Xanadu, one of the early visionary pre-web hypertext systems, is it's finally not too early. It's finally happening. Having worked on smart contracting for 30 years, when I see what's happening in the blockchain space, what's happening as a result of the additional enablers that Satoshi with Bitcoin, and then Vitalik with Ethereum, and the energy, enthusiasm, and the level of activity for all of those smart contracting dreams, it's also finally not too early. And now is the time to realize those earlier dreams, because when we've been watching it, when I've been watching it, people from my community, people I've been collaborating with for those 30 years, have been watching the smart contracts that have happened in the modern blockchain world for one of these things after another, for one of these big bugs that cause tens to hundreds of millions of dollars to disappear overnight with no recourse. When we look at the bugs, we think, oh my God, if they had just been doing smart contracts our way, not all of the bugs, but many of these bugs just would not have happened. It just wouldn't have been an issue. And one of our founders, Brian Warner, was actually one of the people who co-authored the security review of Ethereum.
Yeah.
That was written before the DAO bug. And the security review identifies the hazard that became the DAO bug, and the security review cites my thesis, my dissertation, cites the work of our community, and recommends that in order to build a smart contracting system that doesn't have hazards like this, that the modern smart contracting world should learn from the patterns of the object capability community.
Sure.
So now we've come together to bring our way of smart contracting to this world, because now there's the opportunity, there's the world receptive to it, the world receptive to the message, and the need. So in the starting in the late 90s through the early 2000s, I was doing a research language named E. And a lot of the best thinking about how to write smart contracts intuitively and reliably and without an unreasonable expertise requirement. A lot of that work happened in the community that was built around the E language, and built around the website ewrites.org. And then in 2007, I joined Google as a research scientist and joined the ECMAScript committee at Doug Crockford's prompting. Doug Crockford and I had earlier worked on E back in the 90s. Doug Crockford was heavily involved in JavaScript by the time I joined Google. He convinced me to get onto the ECMAScript committee because he convinced me that JavaScript has the seeds of an object capability language. And so I did. I spent the last 10 years on the ECMAScript committee collaborating early on with Doug Crockford and with Chip Morningstar, who's also a key creator of the early E language, now with Dean Tribble and Brian Warner, two of the co-founders of Agoric. Dean Tribble, by the way, is also a co-founder with me of Xanadu back in the late 90s, late 80s. And we've been collaborating on these ideas very closely for all those years. The thing that stood out to us in doing it with a research language is it was a great success that we were able to get a community of hundreds of people to program in our research language and to explore issues in our research language. You don't change the world, you don't bring the world marketplaces online and cause a revolution with hundreds of programmers programming the new paradigm. Mm-hmm. So Doug Crockford convinced me that JavaScript had the seeds to become an object capability language. I've now been on the ECMAScript committee for, I think now 11 years. And we starting from the seeds of object capability, we've shaped JavaScript to support this well. And now our secure ECMAScript language and our is an object capability language embedded in JavaScript that uses the enablers we got into the JavaScript language so that JavaScript code could enforce that other JavaScript code stays within the SES object capability language. We've been collaborating. This started in Google with the Kaha project at Google. Agoric has now been collaborating with Salesforce. The SES mechanisms are now in the core security kernel of the Salesforce Lightning Network, on top of which sits an ecosystem of 5 million developers. So this stuff is battle tested both earlier at Google and now at Salesforce. It's before the committee. There's other companies that are looking at it. There's other companies where I can't be very specific using it. So JavaScript does support a high quality object capability usage through SES. Then we have a small subset of that, which is for writing highly reliable JavaScript, a subset called Jesse. And Jesse, it's spelled like the person's name, Jesse, but it's actually an acronym for JS JavaScript E. The character of Jesse as a programming language is very E-like. So we've sort of brought the flavor of E into JavaScript. And that's how we're writing our smart contracts. And that's the tooling that we're doing with formal support tools is intended to support the writing of reliable smart contracts in the Jessie language.
Well, it certainly sounds like you've done a lot of research on this. And you've now turned your attentions to Agoric, where you've been for a few months now. And if I might ask, how big is Agoric? Is there
6 people.
6 people at Agoric?
Yep.
And are you hiring? How do I get in on this?
So the answer is, please check out our website. And yes, we are interested.
Engineers, developers, finance, the whole bit?
Yes. So check out the website. Information there about who we're looking for and how you should go about applying to us will all be appearing on the website.
Well, that's wonderful. And is there anything else you'd like to say?
Thank you.
Well, thank you too. That's us from SFCDevs. Thank you very much for joining us.